Okay, so hello and welcome to my Microeconomics lecture series. So this is the lecture on elasticity. So the first thing is so oftentimes people have trouble getting a sense of what elasticity is. It's essentially responsiveness, right? We're going to talk about price elasticity of demand really quick. Price elasticity of demand essentially measures how responsive are consumers to changes in prices, right? We already know when prices change, by the law of demand, we're going to get an expected effect on quantity. If prices rise by the law of demand, we know quantity falls. If prices fall by the law of demand, we know quantity demanded rises. What is elasticity bias? Well, above and beyond what the law of demand is contributing in terms of the direction of the effect, elasticity is telling us how much, how responsive, how big of a magnitude of a change do we get in response to a given percentage price change. Okay, so I want to say that before I do anything else with the slides. That is the key concept with elasticity. Okay. So yeah, we'll talk about elasticity, talk about how to calculate elasticities, applications of elasticity, and the midpoint formula. So once again, we've already understood economic agents to respond to changes in price. That's the primary incentive that we study economic agents responding to. When prices go up, we expect quantity demanded to go down. When prices go down, we expect quantity demanded to go up. This is just the law of demand, right? This is just telling us the direction of the effect. We have a change in price, we have a change in quantity demanded. Not a shift. It isn't a shift in the curve. To get a shift in the curve, remember, you need something other than price to change. This is represented by a movement along the same demand curve. Why do I make a big deal out of this? This really matters, because if we're interested in elasticity, if we're interested in responsiveness of consumers to changes in price, we need for nothing other than price to change. Because in our data, if income changes, if the number of buyers changes, if consumer tastes change, then we are no longer measuring the sensitivity, the responsiveness to price. We have a lot of other things going on. Okay, so that's something to kind of keep in mind in the background. When we're talking about elasticity, we mean a ceteris paribus effect. We mean holding everything constant besides price. We want to know precisely what's the causal effect of a price change on quantity demanded. Okay, so my question so the law of demand tells us the direction of the effect. How big or small are these changes? And then what kind of comparisons can we make across products? That's what we really care about, is let's make some comparisons. So for example, if the prices of gas and milk both rise $1 per gallon, do we expect a bigger or smaller reduction in the quantity demanded for gas or for milk? Now you probably have some pretty good intuition here. You probably have some pretty good existing intuition about what you'd expect to happen. We probably expect the demand for gas to be way less responsive than the demand for milk, because there's fewer good substitutes for gas than for milk. Okay, so now let's make that intuition rigorous. So to do this, we're going to begin thinking about the concept of elasticity. Okay, so first off, there's all different types of elasticities. Right here in the slides, I talk about other elasticities. Besides price elasticity of demand, our main elasticity of concern, price elasticity of demand. And what this is going to do is this is going to tell us something about the responsiveness of quantity to changes in price. With elasticity, think of a rubber band, right? Think about elasticity, responsiveness, right? That's what we're interested in. Okay. Now, this is just going to build the intellectual foundation for what we're doing. So don't let this confuse you. Elasticity is not slope, but slope gives us a really nice window into elasticity, and I'm going to start with that. So we already have a measure of responsiveness, the slope of the line. So we can represent a market demand curve using a mathematical expression like P is equal to 10 minus 2Q. You may never have seen an equation for a demand curve before. That's okay. Remember, this is like y equals mx plus b form. So here's our y, our vertical axis. Here's our x, our horizontal axis. Here's our vertical intercept. Here's our slope. The coordinates, to delineate this line, we're going to have a vertical intercept at 0, 10. We're going to count 10 units vertically, put a point there. And we're going to have a horizontal intercept at 5, 0. Count 5 units horizontally. I'm going to show you the picture in just a second. So what this means is at a price of 0, 5 units are demanded. If the good's free, we can give away 5 units. Cool, right? All right. So at a price of 10, 0 units are demanded. This is like the maximal willingness to pay in the market, and everybody leaves once the price hits exactly 10. The slope of the line is 2. We see this here. It just tells us that for an additional unit of quantity to be sold, the market price got to fall by 2. Right? So if we're here at 0.10 and there's no unit sold, what do we got to do if we want to sell 1 unit? We have to drop the price down to 8, right? Price decrease of 2 gives us an increase in quantity demanded of 1. So that's exactly what my example is. Let's begin at the point where price is equal to 10, quantity is 0. In order to sell 1 unit in the market, the price must fall by 2. Brings us to the point P is equal to 8, quantity is equal to 1. I'm going to show this to you with a graph in a second. Matter of fact, since the slope is 2, this tells us a price reduction of 2 is necessary actually for every single unit increase in quantity demanded. Which is great, but using the slope to think about responsiveness is actually incredibly challenging. Anyway, let's see the picture. So just to illustrate what I was saying, here is our vertical intercept of the demand curve. Here's our horizontal intercept. This is our demand curve. P is equal to 10 minus 2Q. Slope of 2. If we're initially here where nobody's buying, right, this is 0. If we're initially up here where the price is 10 and nobody's buying and we want to sell exactly 1 unit, we've got to cut prices by 2 to sell that unit. And we know that because this thing has a slope of 2. So what this is saying is that for a $2 2-unit decrease in price, we'll get a 1 unit increase in quantity. In some sense, that's responsiveness, right? That's exactly responsiveness. It's not quite elasticity, but it's close. Matter of fact, the calculus definition of elasticity is nothing other than the slope of the line multiplied by this coordinate, the ratio of this coordinate, actually. Anyway. So, all right, so consider some comparisons between, so don't worry if that didn't make any sense, yeah, don't worry about that. So, all right, consider comparisons between 2 goods, steak and eggs. Suppose we have a 10-cent, a dime per pound rise in the price of steak, leads total U.S. steak consumption to fall by 200,000 pounds per week. At the same time, we have a dime increase per dozen in the price of eggs, leads U.S. egg consumption to fall by 25,000 dozen. Was the demand for steak or eggs more responsive to our 10-cent increase? I mean, that's a tough question, right? It's difficult to talk about with like absolute terms. So to solve problems like this, what we actually want to do is talk about percentage changes. So rather than talking about a 10-cent decrease or 10-cent increase, so in this case, well, my example is a 10-cent increase. Here I want to talk about a 10-cent decrease because I want to be able to have a nice clean percentage here. So if we think of a 10-cent, rather than thinking of a 10-cent decrease as a move from, say, $2 to $1.90, we'd call this a 5% decrease in price. That's a much cleaner way to talk about this. Similarly, for a rise from 300,000 dozen to 330,000 per week, we call this a 10% increase in consumption. We want to talk in percentage terms. It's way more concise, way more precise. That's what we're going to do with elasticity. To further facilitate the comparison, we want to actually link together these concepts. We want a causal relationship, So we want to say, if, for instance, a 5% drop in the price of eggs gives us a 10% increase in the quantity demanded, we'd say for each percentage point fall in the price of eggs, we get an increase in consumption of 2%. This isn't yet elasticity. This is just indicating the causal arrow. If variable A affects variable B, the elasticity of B with respect to A is just the percent change in B arising due to each percentage point change in A. Okay. So this is so far as just the intellectual foundation for what we're going to do now. So the price elasticity of demand is just the percent change in quantity divided by the percent change in price. This is a ratio. It's a fraction. It's actually unitless because a 10% increase in price is the same percentage increase, whether its price is measured dollars, pesos, pounds, yen, whatever. Okay. Also, this is a ratio. Epsilon is how we're going to denote elasticity. Percentage change in quantity divided by percentage change in price. This is a fraction. What do we know about fractions? Fractions can range from 0 to infinity. When's this thing 0? This thing's 0 when the numerator is 0. When's this thing infinity? Well, it's infinity when the denominator is 0. When's this thing bigger than 1? It's bigger than 1 when we have a larger percentage change in quantity than our percentage change in price. When's this thing smaller than 1? When the denominator is bigger. Okay, so that's going to be important because we're actually going to define inelastic, elastic, unit elastic relative to numbers, relative to the actual value we get from this ratio. So think about that intuition about fractions I just shared. Okay, but before we get there, actually the sign of the elasticity of demand is always going to be negative. Price and quantity move in opposite directions because demand curves are downsloping. What does this mean? That's just the law of demand. Demand curves are downsloping is just the law of demand. Okay, so we just typically ignore the minus sign and simply refer to the absolute value of elasticity. So lots of times we just remember, oh, if it's price elasticity of demand, of course, by the law of demand, this thing's actually negative. We're just going to speak as if it's positive. And what we're doing is we're taking the absolute value of the elasticity. Why are we doing that? Well, otherwise we might get confused in terms of thinking about magnitudes. So is an elasticity of -3 greater or smaller than elasticity of -2? It's actually more elastic. It's a smaller number, but it's more elastic. So mathematically, -3 is smaller, but the economic interpretation is that epsilon equal to -3 is more elastic than epsilon equal to -2. Thinking about things in absolute value terms is going to be helpful making comparisons. So that's why we do it. It's also important to note that we generally refer to the price elasticity of demand. The elasticity typically takes on different values at different points of a market demand curve. And this is definitely true for linear demand curves. So the epsilon is going to be equal to infinity way up here. It's going to be equal to 0 way down here. It's actually going to be equal to 1 at the midpoint. That's true of all linear demand curves. It's going to be bigger than 1 above the midpoint, smaller than 1 below the midpoint. And I'll show you a picture in a second about a little bit of intuition about what's happening. Remember, we're talking about percentage change in price and quantity. So if price is relatively big, then a given size change is going to be a smaller percentage of price up here than quantity, because quantity is relatively small if we're on this side of the curve. If we're down here, this is where quantity is bigger than price. So a given percentage change in quantity is going to be smaller than a given percentage change in price. I'll show that to you in a second. This area right here, this is the elastic or responsive portion of the demand curve. Here's the inelastic or unresponsive portion of the demand curve. And unit elastic is where demand is proportionally responsive. And I say this on the slides as well. So demand is perfectly elastic when there's an infinite change in quantity in response to each percentage point change in price. Demand is elastic, responsive, when there's a more than proportional change in quantity for each percentage point change in price. This is where the numerator of our elasticity definition is bigger than the denominator. Demand is unit elastic when there's an exactly proportional change in quantity for changes in price, like a 1% change in quantity for every 1% change in price. Relative to our elasticity formula or our elasticity definition, so to speak, it would be percentage change in quantity, 1%, divided by a percentage change in quantity of 1% would be an elasticity, epsilon equal to 1, right? That's what we mean by unit elastic. Demand is inelastic when there's a less than proportional change in quantity for every percentage change in price. This is where the denominator is bigger than the numerator. Perfectly inelastic when there's no change in quantity for any percentage change in price. Okay, and then here are those numbers. Perfect elasticity is an absolute value of elasticity of infinity. Demand's elastic when it's bigger than 1 in absolute value. Demand is unit elastic when it's equal to 1 in absolute value. Demand is inelastic when it's between 0 and 1. So this is like fractions, like ordinary fractions, like 1/2 or 3/4. Demand is perfectly inelastic when epsilon is equal to 0. All right, so sometimes we're going to refer to the elasticity of the entire market demand curve. And this is really useful when we start analyzing the effects of taxes. So when I talk about taxes in the tax lecture, we're going to understand that the incidence of a tax, who bears the burden of the tax, actually depends entirely on the relative elasticity of the curves. It doesn't matter if the tax is implicitly on buyers or on sellers, or explicitly on buyers or sellers. What matters is which curve is steeper. So this concept comes back, is what I'm saying. So when we're referring to the elasticity of the entire market demand curve, we're really asking, is the relative slope of the line flat or steep? I mean, so slope is not elasticity, but they're closely related. So here's an example. Suppose we have a relatively flat demand curve, elastic demand. Well, look what's going to happen. So for a relatively small percentage change in price, going from P1, we have a price increase, to P2, we get a huge decrease in quantity demanded, right? This is exactly what we mean by elastic demand. Think about our expression, percentage change in quantity divided by percentage change in price. Here's going to be a massive percentage change in quantity with a tiny percentage change in price. The numerator is way bigger than the denominator. This is always going to compute, or for this portion right here, not always, but down here, this is actually going to be inelastic. But that would compute a elasticity that is well bigger than 1. Okay, so here's our inelastic demand. So here we have a massive percentage change in price, and we have a tiny percentage change in quantity. Very unresponsive demand. Steep curves, very unresponsive demand. Okay. All right. So we have some other elasticities we care about. So for instance, income elasticity. So basically, think back to our price elasticity of demand formula. All we've done is we've changed the denominator. Numerators, for all our, in economics, for all our interesting elasticities, the numerator is going to be quantity. We're going to always change the denominator. So now the denominator becomes income. So income elasticity of demand tells us, hey, if we have a percentage change in income, what percentage change in quantity demanded is caused by that? Think about how changes in income affect changes in demand. We have definitions for this, normal and inferior, right? Remember, if income rises and you buy more of that good, that's a normal good. If income rises and you buy less of that good, that's an inferior good. So exactly as you might expect, income elasticity is going to tell us about normality and inferiority. So a negative income elasticity tells us the good is inferior. Positive income elasticity, less than 1, would say the good's a necessity. This is like less than 1 means relatively close to 0, somewhere between 0 and 1. This is the denominator is bigger than the numerator, so we have very unresponsiveness here. That'd be a good that's sort of a necessity. It's not very price sensitive. Income elasticity larger than 1 tells us the good is a luxury. So here we have a very responsive, very income responsive demand. That's what we call luxury. Negative income elasticity, the good's inferior. The larger concept here, if your income elasticity is positive, you for sure have a normal good. That normal good could be a necessity or a luxury. Okay, so that is just a further finer grain distinction. We can also use elasticities to investigate substitutes and complements, right? So here we use the cross-price elasticity. Cross-price elasticity is going to give us, for a given percentage change in one good, how does the quantity of the other good change, right? So if we have a percentage change in the price of one good, what's the effect on some other related good? So this works just like regular price elasticity of demand, only the price and quantity come from different goods, two different goods. If the cross-price elasticity is negative, this suggests the goods are complements, right? So this cross-price elasticity is negative. How can that happen? Well, that's if the direction of quantity and the direction of price change go in the same direction. So that means we get an increase in the price of one good, gives us an increase in increase in quantity demanded. We get an increase in price of one good, gives us a decrease in quantity demanded of the other good. Those are opposite directions, so we get a negative cross-price elasticity. So the goods are complements. Suppose we get a decrease in the price of one good, an increase in quantity demanded of the other good. Those are moving in the opposite direction. That would be a negative sign overall. Those would be complements. Now suppose we get an increase in the price of one good and an increase in the demand for the other good. Those are moving in the same direction. We get a positive change in both. That's going to be substitutes. Suppose we get a decrease in the price of one good and a decrease in the quantity of the other good. Those are moving in the same direction. That's substitutes. So complements would be like an increase in the price of hot dogs. So we buy fewer hot dog buns. Increase in price, decrease in quantity of the other good. That's a negative sign, complements. All right. Suppose we have an increase in the price of Coke. We get an increase in the quantity demanded of Pepsi. So those are substitutes. Increase in one, increase in the other. Those are going in the same direction. That's a positive cross-price elasticity. Substitutes. Okay, so the next thing to think about is this link between elasticity and total revenue. So we can see this best graphically, drawing a total revenue curve on a set of axes below the demand curve and marginal revenue curve. And you'd see more formal definition, but those details can wait till intermediate micro if you happen to take the class. Okay, so here is a linear demand curve. This portion is elastic. We've already defined that. The lower portion is inelastic. Here's our total revenue curve. And the way that I've drawn this, what I mean be happening here, is this is the same quantity. Actually, it turns out that the revenue maximizing quantity, see, total revenue is highest here. The revenue maximizing quantity is also the point of the demand curve that's unit elastic. Let me stop for a second. So I've got some pictures that I took from the chalkboard in class. I'm going to show those, but I don't want to do that here because I want to talk about midpoint formula. So after I get done talking about midpoint formula in this video, I'm going to go to my board notes, and that's actually going to provide a little bit more intuition as to why this picture makes sense. I'm going to use a numeric example. So you probably want to come back and look for that. Maybe you want to skip ahead and then see the midpoint formula slides later. Okay, so what's going on here? Well, this is the elastic portion of the demand curve. What's going on with elastic demand? Well, with elastic demand, we know that for a given price change, we get a much greater quantity change. For the inelastic portion of the demand curve, that tells us for a given price change, we get a much smaller quantity change. Well, it turns out revenue is defined as the product of price and quantity. If you want to increase revenue, there's two effects, the effect on price and the effect on quantity. By the law of demand, those goes in opposite directions, but one might be larger than the other. And whether one is larger than the other depends on where on the demand curve we are. If we're on the top portion of the demand curve, the price effect is bigger. The quantity effect is bigger. If we're on the lower part of the demand curve, the price effect is bigger. So what's going on? If we're down here, think about what's happening with a price decrease. So as we decrease the price, we move down the demand curve. As we decrease the price, move down the demand curve, the quantity is rising, we're moving up, total revenue is rising. Because where the demand is elastic, a decrease in price gives us a rise in total revenue. If we continue to decrease the price down the inelastic portion of the demand curve, revenue falls. We keep moving down price, move down the demand curve. Now we're moving along and down the revenue curve. Revenue's falling, right? So in response to a price decrease, that's what these comments are. In response to a price decrease, revenue is increasing where demand is elastic. Revenue is decreasing where demand is inelastic. Let me come back to that in a little bit. Okay, so elasticity and revenue. There's important implications for the effect of a price change. Why? As I said, with revenue, there's two effects. Consumers pay more for the unit. If you raise the price, that's good for the firm. They also buy fewer units by the law of demand. That's bad for the firm. The overall effect depends on which of the two is dominant. If the firm's currently on the elastic portion of the demand curve, consumers are very highly responsive to price changes. That's what elasticity means. An increase in price leads to a decrease in revenue, and a decrease in price leads to an increase in revenue because the quantity effect is dominant. For a given price change, the quantity change is much larger. That has bigger influence on revenue. If the firm is on the inelastic portion of the demand curve, consumers are very unresponsive to changes in price. So now an increase in price actually leads to an increase in revenue because the increase in price is larger than the relatively small change in quantity. And a decrease in price leads to a decrease in revenue. Here the price effect is dominant. The bigger we raise the price, that is a larger percentage change than our decrease in quantity that results when demand is inelastic. So if the firm wants to decrease revenue, if the firm wants to increase revenue, it should decrease the price if demand is elastic, optimally lower the price. If demand is elastic, if demand is inelastic, it should increase the price. And then let's see, is it ever the case that it's optimal to leave the price the same? You think about what this would amount to. This is where we're on the revenue maximizing point. If we're already at the midpoint of the demand curve. Okay. It turns out the price and quantity corresponding to unit elastic is the revenue maximizing price and quantity. If the firm's producing at the point where demand is unit elastic, it's maximized revenue. Any further changes to output would decrease revenue. So when would a firm not want to produce where demand is unit elastic? When would a firm not want to produce at the revenue maximizing point? Well, firms don't care about maximizing revenue so much as they care about maximizing profit. Profit takes into consideration costs, right? So the only time the firm would want to maximize revenue, the only time the firm would want to produce the revenue maximizing quantity is actually when marginal costs are zero, right? You can actually show that a firm with market power, a firm that's price setting, is never going to produce on the inelastic portion of the demand curve. Monopoly would always want to raise its price to the elastic portion of the demand curve. We'll come back to that later on when we talk about market structures. Okay, let me talk about midpoint formula. So there's a couple different ways to calculate the price elasticity of demand. In most classes, most textbooks, they tell students to use the midpoint formula. I actually don't like the midpoint formula, and I'll tell you why. But let me show you the midpoint formula. So elasticity depends on the location on the line of the curve, right? Different elasticities at different points on the linear demand curve. So you can use the midpoint formula so that the elasticity we calculate doesn't matter kind of which of 2 points for a given price change and a different given quantity change. We're moving to 2 different points on a demand curve. If you use the standard point elasticity formula direct from the definition, you calculate a different elasticity at the 2 points. If you use the midpoint formula, you get the same elasticity, and I'll show you that here. So here's the midpoint formula. This is a percentage. This is the change in quantity divided by the average of the quantities. This is in some sense a percentage change in quantity divided by the change in price divided by the average of the prices, percentage change in price. Okay, so we could use this formula for any points, Q1 and P1 and Q2 and P2. So suppose our initial price and quantity is a quantity of 12, a price of 6. In response to a price increase of 2, suppose quantity demanded drops by 6. So the new point is a quantity of 6 and a price of 8. Let's find the price elasticity of demand using the midpoint method. Okay. So here's our initial point, here's our new point, here's our price elasticity of demand formula, midpoint formula. We'll just plug in these values, right? So 6 minus 12 divided by 9, right? 6 minus 12 is minus 6, divided by 12 plus 6 is 18 over 2 is 9. And then for the price portion, we have 8 minus 6 divided by 6 plus 8 over 2, or 2 divided by 14 over 2. Yeah, so 2 over 7. Anyhow, if you calculate this elasticity, it's minus 2.33, which is relatively elastic, right? Relatively elastic. This tells us demand is pretty elastic. We knew that already because we kind of know what point. If you sketch these points out, you'll see we're on the top part of the demand curve, so we knew we had to be elastic. This tells us exactly how elastic demand is. All right. Well, what's the point of using the midpoint formula? Why do we want to use this? Well, it actually doesn't matter if we're moving up the curve from the initial to the new point or down the curve. Things are different if you use what I'm going to call a more naive formula. So suppose this is actually the point elasticity formula. I shouldn't call it a more naive formula. When I actually like this version better now. But anyway, so let's try this formula. So suppose we have a percentage. We're changing from the point of 12.6 to 6.8. The point elasticity formula gives us new price minus initial price divided by initial price. And this is going to be 8 minus 6 over 6, or a percentage change in price of 1/3. If we go from 6.8 to 12.6, this formula gives us a percentage change in price of minus 1/4. These are different, right? The similar work for quantities gives us opposite signs. So we compute the quotient, the elasticity is negative. But the point is, look, we're getting a different percentage change in price if we're calculating going from this point to this point than if we're calculating from this point to this point. All right. So sometimes people criticize this formula because of this fact. More recently, I actually like this better. This is actually the formula that I teach in class. I think this is better. The reason why is we know what the new and initial point is going to be. We don't have to worry about like which one to calculate. We know if prices have risen or fallen. Also, using the midpoint formula introduces quite a bit of error because it's taking the average. The midpoint formula method relies on averages, which are the same for price rises and falls. It gives us the same magnitude and percentage change for price increases and decreases for the reason I just showed here. The midpoint formula. No, not for the reason I just showed there. Do this yourself. Take the midpoint formula and calculate going from one point to the other and then the other point back. You'll get the same elasticity of minus 2.33. And that's why we use it most often for calculations. No. In introductory micro and in principles of micro, we use this most often for calculations. In applied work, probably not. Okay, so what's going on when you're using the point elasticity formula and you're calculating a price decrease from this point, decrease of 2 from 8 to 6, you would actually be calculating the elasticity here, because you would take the new price, or the new quantity minus the old quantity. And then you take the, if you're going down here, you take new quantity minus the old quantity divided by the initial quantity. The initial quantity would put us here. We take the new price divided minus the old price divided by the old price. That would put us here, right? So it's going to compute elasticity here. If you use this as your initial, if you use this as your point, then we'd compute the elasticity here. Well, if you use the midpoint formula, none of that matters. It doesn't matter which you take as your first point or your second point. The midpoint formula is always going to compute the elasticity at the midpoint, halfway in between, at the point 0.97. The midpoint is going to compute the elasticity here. Okay, so that's cool. Okay, so what's the advantage of using the midpoint formula? Well, the midpoint formula is going to give you the same elasticity regardless of what you take as your initial and your final point. So that's cool. What I don't like about the midpoint formula, though, is that this isn't the elasticity. You're not actually at this point. You're either here or you're there, right? So this is introducing some error. Anyway, so all right. Well, as promised, I want to talk about the revenue thing. So here's how I introduced the revenue linked to elasticity in class. Remember, revenue is going to be price times quantity, or R is equal to P times Q. There's two ways to make revenue bigger. You could raise the price, but then the quantity falls, or you could raise the quantity, but then the price falls. And this is due to the law of demand. So, all right. And I say, yeah, this is coming just from staring at the equation. We realize this. Just from staring at this equation, we realize this stuff. Okay. So now let me actually show an example to illustrate. So here's kind of a cool example to illustrate. I said, suppose you don't understand where this parabola is coming from. All right, well, let's take a demand curve. So let's take a demand curve. Price is equal to 10 minus Q. This point is going to be 10. This point is going to be 10. Sorry, I didn't label that in class. All right. The midpoint is 5, 5. This point is actually 5. I should have labeled that as well. Anyway, so let's just plot our demand schedule. So I'm going to use this equation to fill out this table. P, Q, and then P times Q is revenue. So if price is 0, quantity is 10. If price is 1, quantity is 9, and so on. If price is 10, quantity is 0. You get that from the equation. If we multiply this out, we get our revenue. And sure enough, the revenue maximizing point is the midpoint. And the highest revenue is 25. And notice, this is a parabola right here. It goes from 0 to 0, from 0 to 0. And notice, this is the inelastic portion of the demand curve, right? This is the lower portion of the demand curve. Here we have lower prices, higher quantities. And over here, as we go to higher and higher prices, revenue's increasing, because if we're going to higher and higher prices, revenue's increasing. We're walking back up. This is the elastic portion of the demand curve. Here we have high prices. We're up here, and we have low quantities. Here, as we go to higher and higher prices, we go to lower and lower revenue. Higher and higher prices, we're walking up the demand curve and back down the revenue curve. And then just in general, things that tend to make demand more elastic, more close substitutes, more time, more narrow the product category rather than a broad category, and a larger proportion of your budget. Is a little bit, so this is apart from revenue, this is just thing for demand. The more close substitutes, the more elastic demand. It's actually the same as true for all these things. These all follow from substitutes. If you have a longer time horizon, you're better able to find substitutes or alternatives. If you have a more narrow product category, if we're thinking about Pepsi in particular, there's a lot of subs. There's Coke, there's 7-Up, RC Cola. If we're talking about a broader category, there's fewer substitutes. Like if we think about beverages, what are the substitutes for beverages? I mean, like gel, food that's relatively moist, right? There's not good substitutes for the larger category, for the broader category, for beverages. And the larger proportion of budget, look, yeah, you're going to care a lot more about a percentage change in the price of like a car or a house than you are that same percentage change in like a pack of gum or a candy bar, right? Okay, so very good.